What we just did on exercise 3A, the algebra side, is we had this Trig equation. We had to use the rational zero test, figure out some possible rational zeros, test them out with synthetic division. We're going to do the same kind of thing on the next one with trig, except for it has the sign ratio. Okay, so this equation looks exactly the same. It's going to factor exactly the same way, except we're going to have the signs in it. So this should be 8 sine squared minus 6 times sine x minus 1 times sine x plus a half. All this equal to 0. So now we have 3 of these things to set equal to 0. First one, 8 sine squared x minus 6 equals 0. Draw a line. Sine x minus 1 equals 0. And then one more. Sine x plus a half equals 0. First one, add the 6 over, divide by 8. We know that should be sine squared equals 3/4. When I take the square root of that, sine x should be equal to plus or minus square root of 3 over 2. Remember, that's two separate ones. It's the positive square root of 3 over 2 and negative square root of 3 over 2. Got to list all of those things out. Unit circle. We want the y-coordinate to be positive square root of 3 over 2. That's here at pi over 3. So I have x equals pi thirds plus 2 in pi. Also, I have one in quadrant 2, has the exact same sign value. It's at 2 pi thirds. So x equals 2 pi thirds plus 2 in pi. That takes care of the positive ones. Right now for the negative ones is going to be down here in quadrant 3 and 4. That's at 4 pi thirds. And we should have another one at 5 pi thirds. I'm going to list all those out. X equals 4 pi thirds, add the period, and 5 pi thirds. Right. Could you say that's all the thirds? Well, no, you couldn't, because third is at 0, third is over here at pi. Those aren't part of the solutions. Okay, in the middle one, add the 1 over, so sine x equals 1. Where's the y-coordinate equal to 1? Only right there, which is at pi halves. Add the period to it. 2 in pi. That's it. The other one, remember, is negative 1. It's not going to work. Subtract the 1/2 over. Sine x equals negative 1/2. Now we want our y-coordinate to be negative 1/2. Not in quadrant 1 or quadrant 2. It's down here in quadrant 3. That is at 7 pi 6. And we'll have another one over here at 11 pi over 6. So x equals 7 pi over 6 plus the period and 11 pi over 6 plus the period. Look at all those solutions. It's an infinite number of them. There's like 1, 2, 3, 4, 5, 6, 7 times infinity. Wow. Alright, let's say that I wanted just the solutions in the interval from 0 to 2 pi. Not including 0, but yes, 2 pi. So x would be equal to, we can get this 2/3, or this pi over 3, this 2 pi over 3, 4 pi over 3, 5 pi over 3, all those would work. So would this pi over 2, so would this 7 pi over 6, and the 11 pi over 6. We just wouldn't go beyond that. It would be all of those and nothing else.